Welcome to Psydactic Residency Edition. I am Dr. O'Leary, a third-year psychiatry resident in the National Capital Region. Every week, I try to come up with a new and creative way to give the disclaimer that even though I'm a doctor, I'm only human. This podcast itself will never rise to the level of, say, a peer-reviewed article. I don't have the time or the funding source for that. I'm a psychiatry resident, so no institution in their right mind would let me speak for them without strict oversight. In fact, to drive home the point that I represent no institution, and I'm not giving medical advice here, I want to start this episode with a limerick. Ahem. There once was a doc from the capital who could not quite shut off his trap at all. He turned on a mic, the feedback did spike for his psych theatrical rap battle. And speaking of feedback, if you want to give some feedback to me about any episode, you can go to psydactic.com and fill out a form at the bottom of the page there. That's psydactic.com. But please don't give me feedback about the limerick. I already know how awful it is. If you want references or to read the transcript to any episode, then go to psydactic.buzzsprout.com and poke around amongst the growing list of episodes there for the transcript links. If I were to say to you, pay attention, and you did, then most of us would assume that you were also conscious of what you were paying attention to. Attention and consciousness seem almost synonymous, or at least part of the same bigger thing. But are we really conscious of where our attention is taking us all the time? If you've ever observed someone with attention deficit hyperactivity disorder, even if that person is yourself, you may wonder if paying attention to something is the same thing as being conscious of it. Today, I'm going to explore the attention networks, which are the parts of our brain that get really excited when, for example, we see something that we've never seen before, or something appears to be moving on its own volition, or something appears out of place, like an eyeball on the floor, or something reminds us of another thing that we really want. I'll let you pick the example there. There are two somewhat distinct attention networks in the brain, and because they were named by neuroscientists, who are great at spatial orientation, they're called the dorsal and the ventral networks. The dorsal network is uniquely composed of brain matter in the intraparietal sulcus and the frontal eye fields. So the intraparietal sulcus is a depression that separates the superior and inferior parietal lobe. This part of the parietal lobe helps us orient in space and do things like point in the right direction and grab something that we're reaching for. The other main part of the dorsal attention network, the frontal eye fields, lay just anterior to the primary motor cortex, around the premotor cortex area of the brain. And this makes sense because they're primarily involved in helping us move our eyes together synchronously. The intraparietal sulcus helps us orient our movements in space, and the frontal eye fields help us to track things moving in space. So it may seem obvious that they would be integrated into an attention network. In this case, something we've called the dorsal attention network. The ventral attention network also has two primary regions contributing. There's a region that contains the temporoparietal junction and the supramarginal gyrus, and a region called the ventral frontal cortex. Now that's a lot of words to get lost in. The location of the temporoparietal junction is in the name, And its neighbor, the supramarginal gyrus, is the gyrus right where that line created by the flappy temporal lobes meet the parietal lobes. But what's the ventral frontal cortex? It is not the ventromedial prefrontal cortex. That was part of the default mode network I talked about before. The ventral frontal cortex that is part of the ventral attention network is distinct. It is just beside and above where the anterior or the front part of that flap of the temporal lobe hugs the frontal lobe. Maybe it would make more sense if I explained it like this. Imagine a mushy brain's just sitting on a table in front of you, and it's oriented in the same direction as the brain in your own head is. If you grab that mushy brain by the lower sides, you've grabbed the temporal lobes. If you run your thumb along the margin between the temporal lobe and the rest of the brain until you get to the front, and then touch the part of the lobe just next to it, you're touching the ventral frontal lobe, specifically the frontal operculum. They call it the operculum because if you lift it up, you'll see the anterior insula just underneath of it. So it's like a window to the insula. Now, slide your thumbs back along that same margin until it's in that crack of the brain right where the margin ends and the parietal lobe begins. That is the supramarginal gyrus you're violating right now. And then go a little bit further back past that, and you're at the junction of the parietal lobe and the temporal lobe, or the temporoparietal junction. I wonder how much of my parietal lobe was involved in coming up with that imagery just now. So now, drop that floppy brain down on the table, appreciate its satisfying jiggle, and let's get back to work. The parts of the ventral attention network near where the parietal and temporal lobes come together are responsible for being able to recognize details in spatially oriented stimuli. In classic experiments, lesions in this area might make someone unable to see that a bunch of letter E's arranged in the shape of an S were not just a big S. Metaphorically, you could say that this part of the brain is necessary for picking the trees out of the forest. The ventral frontal parts, that operculum and maybe even parts of the anterior insula, are involved in, well, I'm not quite sure. All the descriptions I found were either vague or the language was so technical that I couldn't really follow it. But there is a lot going on in that part of the brain, and it seems like this part of the brain might be important for integrating information from multiple senses and deciding what to give the most attention to. So instead of looking into the environment and picking out little details like the parietal parts of the ventral attention network do, it integrates multiple senses in order to figure out what details are important. I've read the term flexible decision-making used to describe this region of the brain in multiple papers, but I don't know really what that means. Comparisons with macaque brains have shown that we have a lot more going on in that region than they do. So this part of the brain might be particularly important for making humans human. It's commonly reported that the ventral attention network is right side dominant, but some researchers have questioned just how dominant that dominance actually is. But that's beyond the scope of this episode. To summarize again, there are two primary attention networks. There's the dorsal attention network, composed of the intraparietal sulcus between the superior and inferior parts of the parietal lobe, and those frontal eye fields right in front of your motor cortex, which help us to focus on things and track those things through space. You could call it our space-time system because it helps us maintain task-driven focus over time on objects moving through space. The other is the ventral attention network, composed of areas around the temporoparietal junction and the ventral frontal cortex. And this helps us pick details out of our environment to pay attention to and make decisions as to what we need to focus on. Some have characterized the dorsal attention network as a top-down network, meaning that it tells the rest of the brain what to pay attention to, like an executive giving commands to its managers. The ventral attention network has been described as more bottom-up, which it takes details and sensory information from the environment and brings that to the attention of the executors, who can then decide what to do with it. I'm sure, though, that any simplified characterization like this is probably missing something. But what are we supposed to do with all of this attention that we could be giving to things? How do we really decide what's worth giving attention to? How do we stay on task without getting distracted by other things? How would we know when we need to get distracted? How do we not get distracted by things like our own thoughts? In the next episode, I'm going to discuss something called the salience network, which gives value to different things competing for attention. The dorsal attention network can maintain attention through space-time, and the ventral attention network can pull out details from some of that noise and provide those to our brain for decision-making. But it's the salience network that really decides what details are important and need action. But that is for next time. I am Dr. O, and this has been an episode of Psydactic Residency Edition.